Hi everyone. In this video, I'm going to show you how to calculate the mean, the median, the mode, and the range of a dataset. But this dataset is given in the form of a frequency distribution table. So let's look at this table. Let me adjust my camera. So we have this frequency distribution table. Let me give you a little bit of background information. In any frequency distribution table, the first column represent the values. So in this case, they represent stress level of college students. So level 1 represent no stress, and level about 5 represent middle level stress, level 10 maximum level of stress. And this numbers frequency represent number of students who feel that stress level. For example, among all of the surveyed students, 2 of them felt no stress at all because this stress level is 0. About 18 of them feel middle level of stress. 14 of them felt like a maximum level of stress. So that's the meaning of this table. And if you add all of these frequencies together, it's total frequency. Actually, it represents total number of students surveyed. So that's the basic information now. And a second piece of information I'd like to mention before we do the calculation part is that all of these statistics, the mean, the median, the mode, the range, all refer to the data value. It has nothing to do with frequency. That means when we calculate the mean of the data set, that's the mean of values. That's mean average of these numbers. Median of these numbers. Mode of these numbers. And the range, also the range of these numbers. Okay. Now, let's do this one by one. First, the mean. Mean means average. So everybody learned how to calculate the average, right? For example, you have 5 numbers. You want to calculate the average of those 5 numbers. And what do you do then? You add them up, add those 5 numbers together, then divide by 5. You get an average. And that average is called simple average. Now in this video, we are going to learn how to calculate the weighted average. Why we call it weighted average? Like weight. Why we call it a weighted average? Because you have these frequencies. Say 1 occur once, but 3 occur 12 times. These frequencies are called weight. And let's say, to see if I can show you how to calculate this so that you understand it. Now, let's say this value 0 occur twice. So basically like this, 0, 0. And 1 occur once, so I get 1. And 2 occurs 3 times, 2, 2, 2. And 3 occur 12 times, 3, 3, 3, and so on. Totally 12 threes. You can write them all. And if we add all of the frequencies together, and let's see, I didn't add it actually. Let's add it, let's say, 3, 6, 18, 34, 52, 65, 96. 96, these two make 40, and this make 40, and 136. 136 plus 15, 151. So totally 151 students. In other words, actually we have 151 numbers because each student got a level of stress, right? You have 151 students, you have 151 stress levels. It's just that some of them will repeat, like 3, like 2, but you have 151 numbers. So in terms of calculating the average, which is called mean, you would add all of those 151 numbers together and then divide by 151. Is that right? Actually, it is right. That will be called simple average. You add the number of number, all of the numbers together divided by the number of numbers. Then you get a simple average. But even though theoretically it's okay, but practically it's tedious to do calculation. Sometimes it's almost impossible to do calculation. For example, we only surveyed 151 students in this case. So everybody can add 151 numbers together and divide by 151. What if you have a larger data set? For example, in the University of California system, they have more than 150K students. So if they surveyed all of those students, you're going to have 150K numbers to add them together one by one. Again, in theory, everybody can do that. Are you going to add 150K numbers one by one using your calculator? Just push a button all the time. By the time you put in all of 150K numbers, I'm sure it's wrong already because you lose track of it. Or maybe you push that one button wrong, the whole thing will be wrong. So that's why, even though theoretically speaking, we can still do it that way, we don't want to do it that way. That's why we have frequency distribution table. No matter 150K students or 100 million students, you still have 10 levels. You just frequency getting bigger and bigger, these numbers. But we still only have 11 pairs of numbers, no matter how many students. That's why we want to be able to calculate the average, all of the statistics using frequency distribution table. It's just more efficient. So if we use the old method, simple average, by adding them together, I will add 0 plus 0 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3. Again, we have 12 threes, right? And sure, that we can add together, but there's easy way to do calculation. 2 plus 2 plus 2 is 6, right? How many twos? That's 3 twos, right? 2 times 3, is that 6? Yes. If you have 12 threes, instead of adding them one by one, you have 12 threes. Why not using 3 multiplied by 12? If you have 12,000 threes, you just use 3 times 12,000. It's way easier than adding them together one by one. Is that right? It's still equal to the original if you add them one by one. The result is the same. So what we did here is the value times frequency. This value times frequency. It is equivalent to you add all of the values together. So first step, in order to add all of the numbers together, you multiply the value with frequency, value with frequency, value with frequency, like here, value with frequency, plus value and frequency. Value is 1, it only occurs once, so frequency is also 1, plus value frequency, plus value frequency. This way you get a total value. Then you divide by total number of numbers, which is the total frequency. Then you get average. So let's do it that way. Multiply them together. 0 times 2 is still 0. 1 times 1 is 1. 2 times 3 is 6. 3 times 12, 36. 4 times 16, 64. 5 times 80 is 90. 6 times 13 is 78. 7 times 31, 30 times 7 is 210. 1 times 7 is 7, so 217. 8 times 26, 8 times, let me use calculator, 8 times 25 is 200, so 208. But let's make sure. 26 times 8, 208. And this is 208, and this is 144. Oh, sorry about that. 135. Make sure. 9 times 15, 135. And this last one is 140. So now I'm going to add them all together to get the total values. So after I add all this together, it's equivalent to I add all of this 150 numbers together. Again, this total number is 150. It's just the sum of them repeating. So let's do that. And 0, let's do that so that you can see it. 0 plus 1 plus 6 plus 36 plus 64 plus 90 plus 78 plus 217 plus 208 plus 135 plus 140 equals 975. So 975 then divided by the number of numbers, which is 151. So this is the mean. Even though we call it weighted mean, we call it weighted mean because we use these frequencies as part of our calculation. It is equivalent to you don't use a frequency. Instead, you write all of these 151 numbers, add them together, divide by 151. Eventually, it will be equal to the mean. So 975 divided by 151. So 6.45. I don't know, less equal 6.45. So let's take just one decimal digits. So 6.5. That's the median. Oh, that's the mean. I'm sorry, that's mean. So we get mean. Now, give me just 1 second. Let me. Because I'm recording this video, I don't want to give you anything that's not true. As a result, I just try to use this Excel to do this mean really fast. So that you know this is true. I just want to verify that, nothing more than that. So give me a moment. Okay, I'm going to input these numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I get a 2, 1, 3, 12, 16, 18, 13, 31, 26, 15, and 14. Okay. Oh, 975 is correct. I believe we're okay, we're right. Yeah, 6.4569. Yeah, that's exactly correct. Okay, so we finished this calculation of the mean. Now let's look at the median. We're going to use the next page to do the median calculation. This is exactly the same table. Now, before actually we do this calculation, I'd like to show you how to calculate the median efficiently when you have a frequency distribution table. Again, imagine the median is the middle number in the ordered data set. You have 151 numbers. So if you do it in a traditional way, you have to lay out in this 151 numbers and try to figure out which one is in the middle. And you're going to have long line. But if you see the 151 still okay, how about 150K numbers? Try to find out the number in the middle. That's not the way to do it, you know it. So now I'm going to show you a different way to do that, very efficient. No matter you have 151 or 151K, the amount of work almost identical. Okay, first, in order to be able to do that, let's briefly review how we find the median. At the same time, using this two very simple examples, I'm going to introduce a median location formula. So basically, we want to know where that number is sitting in this whole data set. We just go there and pick out that number. That's going to be our answer. So that's our strategy. Now median. Median is the number sitting in the middle in an older data set. So I'm going to create an example here in order to derive that median location formula, which is very simple in the end. So example number 1. So I have these numbers, 10, 17, 4.6, -5, and 8.9. So suppose this is our data set. I line them up first. I have -5, then I have a 4.6, and then I have 8.9, then I have 10, I have 17. So I line them up from the smallest to the largest. So you know this is the median. So in this case, our answer is 8.9. Okay, finish 1. Now let's look at our example 2. This is our data set. I have 10, 11, 5.5, 4, and 6, 1, 2, 3, 4, 5. Let's get one more number. Let's say 8. This time we have 6 numbers. Before we have 5. So this is the odd number of numbers. You only have one median, which is the middle. And you have one number in the middle, so that's our median. Now we have even number of numbers. You already learned that in this case, we are going to have 2 numbers sitting in the middle. As a result, the median will be the average of those 2 numbers. So apparently I need to line them up first. I got 4, 5.5, 6, 8, 10, 11, 1, 2, 3, 4, 5, 6, right? These 2 are in the middle. So we do average to get the median. Median equals 6 plus 8 divided by 2, that's 7. Now, so far so good, because you learned this before, and this is a simple calculation. Again, imagine if this long number is not 5, 6,000, it's very hard to write them out to find out which one is in the middle. Now, let's introduce the median location formula. Okay, now let's look at these 2 examples again. Now, first, this median location formula is very simple. It's n plus 1 divided by 2. How simple is that as a formula? N represents how many numbers you have. So plug in, you get the location. Let's test it out to see if this is right for example 1 and example 2. So for example 1, since we have 5 numbers, so n equal to 5. 5 plus 1 divided by 2. 6 plus 1, 6 divided by 2 is 3. This just tell you in your ordered data set, the number 3, the third number is your answer. 1, 2, 3. Is that right? This is our answer. We just go there and pick it. Okay, second example, we have 6 numbers. So n equal to 6. So location is 6 plus 1 divided by 2. That's 3.5. How come location is 3.5? Actually, this make a lot of sense. 3.5 is between 3 and 4, in the middle of 3 and 4. This decimal just an indication that you have 2 numbers sitting in the middle. You need to pick number 3 and number 4 and divide by 2 to get the median, because 3.5 is between number 3 and number 4. This is location. This number represents location. Between number 3 and number 4, look at this data set. This is number 3, this is number 4, add them together, divided by 2. That's your median. It works again. So in other words, in order to know where the location median, all you need to know is n. What is n? Total number of numbers. That's the total frequency. We have 151. Or n is 151 in this case. So now let's find out the median of this data set. So in our data set, n equals 151. Because when you add them together, totally 151 students, you're going to have 151 numbers. Some of them repeating, but you have 151 numbers. So location of our median, 151 plus 1 divided by 2, that's 152 divided by 2, that's 76. Number 76, if you imagine, if you line up all of those 151 numbers, pick number 76. And that's our answer. So the thing is, we cannot line them up, right? So now we can still do that, still be able to do that without lining them up. And just watch this closely. We need number 76. I'm going to rewrite these values one by one, not all of them, so certainly, and just figure out a pattern. Then we use that pattern to figure out the value sitting in this place. So we have a 1 0 here, 2 zeros, sorry about that, 2 0, and 1 1, 3 2s, 3 2s. So 3 2s, and 12 threes. I'm going to write the 12 threes. This is for the purpose of teaching. After you understand that, you don't need any of this. 3, 3, 3, that's 4. Another 4 threes. Oh, 1 2 3 4, 1 2 3 4. Another 4 threes. The next going to be 4 and so on. Let me double check. 1 2 3 4 5 6 7 8 9 10 11 12. That's right. Now here's the thing. I'm going to add these frequencies together. 2 plus 1. 2 plus 1 is 3, right? 2 plus 1, that's 3. When you add them together, that gives you 3. What does this mean? This is a frequency. That means the value corresponding to this 3 is here, is 1. That means this third number in your lineup here, the third number in your lineup is last one you see, because the next one going to be, when you go to the next frequency, going to be 2. So this is the last one you have. Number 3 is the last one. 1 2 3, is that right? Number 3 is the last one. Continue add. This is 3 plus 3 is 6. Number 6, actually there's TH. Number 6 in the lineup, you're going to see the last 2. The last 2. 1 2 3 4 5 6. Number 6 is the last 2. Let's just do one more. Now, when you add 2 to 1 is 3, 3 plus 3, 6. 6 plus 12, that's 18. Number 18 in your lineup is the last 3 in terms of value. Let's look at that. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Number 18 is the last 3. As long as you see that pattern, it's very easy to figure out the median, because the median is one of those numbers. We are not looking for number 18th, we are looking for number 76, but we use the same pattern. Okay, let's continue. We need number 76. I continue to add because it's far away from 76. 18 plus 16, 34. 34 plus, let me write down this after you add them together, this is 34. Add them together, that's 52. Add them together, 65. Now close to 76, right? If you add one more, this is going to be 96. It's over. So 76 must be somewhere in the middle, right? Somewhere in the middle. Well, our number is in the middle. But don't forget, we need a number that are corresponding to number 76 exactly. We cannot guess. So number 65th is the last 6. So if you have all of the 6, okay, all of the 6 here. We don't care how many, but this number 65 represents the last 6. So it's the number 65th here. This last 6. What does that mean, last 6? The next value will be 7. You have a -7 here. How many actually? 31 sevens. You have many 7, and then you have 8, and so on. But let's look at number 96. Number 96 is pointing to the last 7. So the last 7 is number 96, which is our location, 76. Where's 76? 76 has to be somewhere between 65th and 96, right? And starting from number 66, it's already 7. And in between, they're all 7. Ours is 76. So what do you say for our value? It has to be 7 because all of these numbers are 7 in between. So our median is 7 because this number pointed to the median, this median location number. This must be 7. So our answer, median equals 7. This is just beautiful. Even if you have millions of students, just adding them together, you can find median quickly. Use this method. Okay, now what else we have? We have a mode and the range of the data set, and these two are super easy. So next one, we're looking at the mode. Remember the definition of the mode of a data set. The mode is the most frequently occurred number or numbers in the data set. If you have 2 numbers occur most frequently, you have 2 modes. If you have 1 number that has highest frequency, then you have just one mode. Now this is super easy because it's a frequency distribution table. We just look at which number has highest frequency. 31. Everybody can see that. What is the value for that? 7. In other words, 7 occurred most frequently. So mode is 7. The last one, range. Again, all of the statistics refers to the data values. This is not frequency, okay? Apparently, our value range represents the difference between max value and minus the smallest value. That's called a range. Maximum value is 10, smallest value is 0. So 10 minus 0 is 10. Double check to see I have any questions or not. No, that's all of the 4 questions. Mean, median, mode, and the range. So we finished this 4 questions, and also finished this video. Bye everyone.